like a bowling pin knocked down.
Hello, everyone, and welcome to another Virtual Science on Tap. I'm Linda Deck, the director of the Bradbury Science Museum, and you have come to learn from the experts themselves about some of the latest, coolest research that's going on at Los Alamos National Laboratory. Today's topic, using fuel cells to keep on truckin' with Rod Borup. Science on Tap is a program of the Bradbury Science Museum here in Los Alamos, New Mexico, with support from the Los Alamos Creative District. We thank Lauren McDaniel, the Los Alamos Main Street Director, and the Los Alamos Creative District Curator, Jeremy Smith, for their support in getting the word out about this event. And here's Jeremy to tell us a little bit more about other events going on in the Los Alamos Creative District. Jeremy?
Thanks, Linda. Absolutely looking forward to tonight's presentation. But yes, we do have some other things going on in the Creative District. Tomorrow, I've got the Tuesday at the Pond series. So it's a 10-week music event every Tuesday until August 3rd. Tomorrow, I've got Professor Penguin. I think I still have a few tickets left, so you can check out the website, creativelosalamos.com, or go to the Facebook page and you can get the link to the Eventbrite to get some tickets. We are still limiting capacity for those shows until July rolls around. And so tomorrow, Professor Penguin. I think it'll be a fun one. So if you're interested in some live music in town, 6 to 8 every Tuesday. Also, next Monday, I've got History on Tap. So we will partner with the Los Alamos Historical Society for that. And we will have a panel that will discuss the history of the Los Alamos stables. So if you're interested in that, go to, once again, the website, creativelosalamos.com. You can get the link to register for that virtual on tap. And that may be the last one virtually this year. We'll see how things go. I've also got Science Fest coming up. So we partner with the Creative District, Los Alamos Main Street, a number of other entities. Bradbury Museum is one of our partners for that. So Science Fest this year, July 6th through the 11th, we will have one in-person event each evening at 6 o'clock. And of course, Tuesdays at the Pond will be happening. So the Hill Stompers will be playing July 6th to kick it off. We'll have a short panel discussion and beer provided by the Bathtub Row Brewery on that. And I think we've also got a Science on Tap that Friday, but I'll let Linda tell you about that. So once again, my name is Jeremy Smith with the Los Alamos Creative District, and I'm looking forward to this evening. Thank you.
Jeremy, thanks so much, and thanks for teeing up what I exactly am going to talk about next, indeed. So next month, Science on Tap will be part of the Los Alamos Science Fest and held as a live event. We're so excited about it. So fan favorite Dr. Harshini Mukundan will share her insight into her team's new approach to a blood-based tuberculosis diagnosis. Using biomarker detection, this method could have significant impact on fighting the world's most deadly single infectious disease. As part of Science Fest, this Science on Tap will be on Friday, July 9th. So take note of that, not our usual third Monday, but Friday, July 9th, and it will begin at 5:30 on the lawn of Fuller Lodge here in Los Alamos. If you can't make it live, but I sure hope you can because it's great to gather in person, if you can't make it live, you can watch it and other Science Fest events through Zoom. There are more details at their website, which is losalamosciencefest.com. So I urge you to go there and check it all out. Here's how tonight's Science on Tap will work, and maybe this truly is the last virtual Science on Tap, but this is how it's working and will continue to work tonight. You have joined us virtually, and we're so glad you have, because you are an essential part of the whole production. Our presenter will give about a 15-minute, maybe 30-minute introduction to the topic, give you a bunch of background, and ideally create a lot of questions that you want to ask and understand more about. When he finishes, it will be up to you to ask those questions and keep the conversation going. So please write your questions into the Q&A section of the this live webinar, not the chat. Write it into the Q&A, and then I will be able to see them and I can ask them of our speaker. And I hope we can have a lively conversation. So our presenter today is Dr. Rod Borup. He has been a scientist at Los Alamos National Laboratory since 1999. Leading up to this, he received his BSE in chemical engineering from the University of Iowa in 1988, his PhD from the University of Washington in 1993, and became a postdoctoral researcher here at the laboratory in 1994. Rod is the former director for the Multi-Lab Consortium for Fuel Cell Performance and Durability, and is the current co-director for Million Mile Fuel Cell Truck. He also holds a research professorship at the University of New Mexico in the Chemical and Biological Engineering Department. Rod is a fellow of the Electrochemical Society, and last year won the Los Alamos National Laboratory Fellows Prize for Leadership. Quite a distinguished career already. He's here not wearing one of his signature Hawaiian shirts, which is just what I've been seeing him wear all the times we've met. But it was really hard to get a Hawaiian shirt that didn't have blue in it. Now we're in front of a blue screen. So congratulations, Rod, for finding that nice red shirt. Please, everyone, welcome Dr. Rod Borup. Rod?
Thank you for the introduction, Linda. So as Linda said, I'm going to talk about the fuel cell program and some of our fuel cell work that's ongoing in it, with the title Using Fuel Cells to Keep on Trucking, specifically because the new Los Alamos National Lab-led consortium is Million Mile Fuel Cell Truck. So I'm actually going to start out a little bit and talk about hydrogen and greenhouse gases. This current administration, back in April, President Biden announced some of the work that's affecting our lives and directing some of our research. And there's a lot of words on this slide, but if you just concentrate on what I've outlined under in red, they've directed people like us to work on greenhouse gas reduction of 50% by 2030, and to get the U.S. down to net zero emissions by 2050. And both of those are challenging targets. And in response to the administration announcements about what we're going to do related to climate, Secretary Jennifer Granholm came to our annual merit review being the Hydrogen and Fuel Cells Technology Office, which is the first time we've ever had the Secretary of Energy come to it, and she launched the Hydrogen and Energy Earthshot. So what is this program? And note that this was launched only a couple weeks ago. It's primarily about hydrogen, getting the cost of hydrogen down, getting to the point where you can make renewable hydrogen, make the hydrogen from renewable sources, and so really get the greenhouse gas footprint down. And they announced a lot of different targets related to that. But I wanted to go to this slide and explain the benefits of hydrogen related to the overall U.S. Greenhouse gas sector. I think most people are familiar using renewables, primarily solar, wind, hydro, for the grid. Of course, there are other ways you can make low CO2 electricity, and that includes nuclear, and it includes fossil with carbon capture. Once you have a grid that is primarily based off of renewables, you end up with a lot of different things like storage problems. And so you really have to store energy. In our case, we want to take the renewable electricity that's made, make hydrogen, and then we will use that for the transportation sector. That includes trucks, automobiles, locomotives, and marines. The other part that isn't talked a lot about is CO2 emissions related to energy, industrial processes, things like metals production and ammonia, and that's another place where hydrogen can play. And so what this really is an overall conceptual way that you can talk about decarbonizing the three energy sectors of the country, which is really grid, transportation, and the industrial sector. And we think, especially those of us that work on hydrogen technologies and fuel cells, this is one of the only ways to decarbonize the entire energy sector for the United States all at once. And that's really where a lot of our work is headed. So I'm going to give some background on fuel cells, just so people that know what they are and where they've been. Fuel cells are really not a new technology. And so what's here in the right picture is actually, I think, a mock of what General Electric made back in the mid-1960s. And those actually flew on the Gemini spacecraft. Then I think more famously, fuel cells flew on the Apollo missions that went to the moon, and this is a cutaway picture that I found of the gas storage tanks, which were both hydrogen and oxygen, fed the fuel cells, and that's really what both made the power for the Apollo space modules, plus gave them the heat to keep the modules warm. So different than the space applications, we're trying to work on fuel cells for transportation. And of course, when you start selling commercial products, that's where the change really comes into. You have to have cost reduction. Whereas NASA require, their primary goal is reliability. And after that, it's typically reliability and sometimes weight. When you get to consumer products, it's really about cost reduction. So we spend a lot of time working with a lot of different companies out there, and I took this from one of the main partners we've worked with over the years, and that's General Motors. The automotive OEMs are looking at PEM fuel cells for transportation. They, of course, are also looking at battery vehicles. And there's been a lot of announcements lately from both GM and Ford in terms of the U.S. automakers talking about electric vehicles. And one of the things that should be noted is battery vehicles they see as part of the solution to get to zero emissions vehicles. They also see plug-in hybrids, and they see fuel cells as part of the solutions to get to zero emissions vehicles. They do envision a world where not necessarily one vehicle suits all consumers, and basically all the major automotive companies that are out there all have battery programs and all have fuel cell programs. So when you hear people like General Motors talk about electric vehicles, that means both battery vehicles and fuel cell vehicles. So in terms of differences between fuel cells and batteries, I think everybody's familiar with batteries. You go to the grocery store, you buy a battery. A battery stores the energy inside the battery, whereas a fuel cell converts reactants, in our case hydrogen and generally oxygen from air, into electricity. And so a fuel cell runs as long as you're feeding it the different reactants. So in some cases, batteries have advantages over fuel cells. In other cases, fuel cells have advantages over batteries, specifically at lower driving ranges or how long you want to operate a system. Batteries tend to have an advantage. As you go out to longer and longer ranges, needing more energy, then fuel cells can have an advantage over battery vehicles. And that's one of the reasons why our program is concentrating on heavy-duty trucks. And when I say heavy-duty trucks, I'm talking about the Class 8 trucks, generally referred to as semis out there, because those are the long-haul trucks that have to carry big weight loads, and that's where we think fuel cells have a big advantage over battery vehicles. And we're trying to develop the hydrogen infrastructure that can eventually lead more to the light-duty vehicles. So people that aren't familiar with fuel cells, they are out there. You can purchase them if you live in the right parts of the world. In this country, that's primarily California. Toyota is selling a fuel cell vehicle, Hyundai is selling a fuel cell vehicle, and Honda is leasing a vehicle. And it's primarily located in California because California tends to lead the way in terms of alternative energies and zero emissions legislation. And they, in this case, have more of a hydrogen infrastructure than exists elsewhere. So you can't buy one in New Mexico right now, and a lot of that is because we don't have a hydrogen infrastructure where you can go fill up the car with hydrogen. That is something that we are trying to promote. Our neighbors to the north up in Colorado are also trying to promote that so that we could provide a corridor of hydrogen in between the different states, and then hopefully in the future you can buy a hydrogen fuel cell vehicle. I mentioned most of the automakers out there have hydrogen vehicles. Most of the major automakers have demonstrated vehicles, but they're just not selling them yet, and a lot of that is because of the hydrogen infrastructure. But up here in the upper left is a GM vehicle, and I happen to have driven that. I've also driven Hyundai and Toyota vehicles, but Daimler, Ford, and like I said, the other major automakers have been demonstrating vehicles, and they have them and they're ready. They're still expensive, and so that's one of the things we've been working on is trying to reduce the cost to the consumer. More recently, within the last couple of years, the Department of Energy has really moved our program much more to heavy duty, and that includes buses and trucks. And so you can see that some of the demo trucks are out there, and you've got a number of companies, some startup, some existing, that have been developing hydrogen fuel cells for Class 8 trucks. And then there's been bus fleet demos, again, lots of times like cities like Los Angeles and the Bay Area demoing buses. And that's easier to do because you can have a centralized hydrogen refilling than in terms of trucks. You know, one of the obvious questions as I started out talking about greenhouse gas reduction and what's the advantage of fuel cells, because really today the hydrogen comes from natural gas. So when you look at what today's internal combustion engine is, you can see that the gasoline engines are up there more towards 430, and that's grams CO2 per mile. As you get down to hydrogen fuel cell vehicles, where the hydrogen is made by natural gas, steam reforming of natural gas, and then distributing that natural gas, we're not down at zero CO2, but you can see that it's greater than a factor of 2 reduction in CO2. Of course, what we really want to do is get down to renewable production of hydrogen from things like wind, solar, fossil fuels with sequestration. Nuclear is a good way to make hydrogen, and then you can get down to very low amounts of CO2 in terms of driving the vehicles. So what's been driving part of the move to heavy-duty vehicles is a whole lot of zero emissions legislation. This is an area where the United States really hasn't led in terms of legislation recently, and this is a list of countries. It's not all-inclusive. For example, I know Germany has passed legislation, but you can see some of the legislation is coming, and that's got a lot of countries and developers trying to figure out exactly, you know, when you get to a requirement of zero emissions legislation, how are you going to move your goods around? And that's driving the truck market much more than the light duty market. In response to a lot of the other countries' legislation, in June of 2020, just last year, California did announce new rules that said half of the trucks by 2035 are going to have to be zero emissions trucks, and all of them by 2045. And I think that's really what California intended to do. But something else happened in 2020 that really pushed California to go a step further, and that was the intense California wildfires that happened, which most people would say are due in part due to climate change. And so by September of 2020, they came out and announced zero emissions legislation due to for light-duty vehicles. And so that's driving the DOE program. It's driving our program for heavy-duty trucks because you need to be able to move goods. So I'm going to get now to some of the Los Alamos work. And this is actually a reasonably old slide, but it's part of what we're famous for. Back in the late 1980s and early 1990s, Los Alamos was the first to develop an electrode technology where we took proton-conducting ionomer, mixed it with dispersed platinum catalyst, and this invention decreased the platinum loading by a factor of somewhere between 40 and 100. And it's actually got a lot of the automotive manufacturers and developers interested in fuel cells. And that's when GM and Daimler, for example, started their fuel cell programs.
So Rod, when it reduced that platinum load, what exactly did it make it less platinum that you had to use, or what did that do?
So platinum is a noble metal. It's a little bit like gold, and it's very expensive. So by reducing the platinum loading down by a factor of 40 or 100, you could sit down and calculate on paper that now we think we can afford these for light-duty vehicles.
So it really reduced the amount of platinum that you would need to have.
It reduced
Got
the
it.
amount of platinum and reduced the overall cost of a car. And like I said, so we actually had GM working here at Los Alamos from 1990 to 1996, and primarily because of this set of breakthroughs. The other thing I wanted to mention on this slide is actually two more things, which is we've had a continuous fuel cell program since 1977, and the DOE Fuel Cell Technologies Office grew out of what started at Los Alamos in 1977. And the cars that I mentioned earlier all rely on the technology developed here at Los Alamos, so our technology is inside those cars.
It's one of those kind of hidden, to some people, inventions that came out of Los Alamos that's going to affect everyone that you just don't think about, like heat pipes, like the Monte Carlo simulation. Fuel cells could be that, and probably are already.
I mean, I think in our little world, we're recognized for this invention, but, outside of the fuel cell world, people don't know that, we've had the biggest fuel cell component R&D program, dating back to the 1970s.
There you go.
So I mentioned that we are now working on fuel cell trucks. One of the obvious questions is batteries or fuel cells. We actually think that that's not the right question. We do think batteries have a role, especially in light-duty vehicles. And this isn't my slide. I took this from Kenworth, which is a popular trucking company. And they're comparing the load for a diesel engine versus a compressed hydrogen fuel cell vehicle versus a battery engine. And seeing in terms of what you get for, in their case, they calculated it for a 350-mile range, and you can see what it does to the load. You have to store a lot of batteries on board that vehicle, much less in terms of the hydrogen storage. Both are slightly less than the diesel engine. But again, part of what's driving our program is the zero emissions legislation. And that's both greenhouse gases and it is pollutive emissions such as particulate matter. And I think everybody's seen the black smoke that comes out of diesel engines. So as you go to heavy-duty vehicles, total cost of ownership becomes much more important than the initial cost that you put into a vehicle, and that's the cost coming off of a lot. That's what most people who buy cars look at, is the initial cost. And this was a study by a company out of Vancouver, Canada, just in their cases saying that the total cost of ownership, when you get to certain hydrogen prices, the total cost of ownership can be very competitive across the three. And so it really comes down to what range do you want the trucks to go? Do you want them to go across the country? Do you want them to cross the Rocky Mountains? But the total cost of ownership, you can see, is very competitive between the three by their study. So another important facet of our program is we don't work by ourselves. We almost never work by ourselves. I mentioned the Million Mile Fuel Cell Truck Consortium. We co-lead that with Berkeley National Lab. We're working with 3 other national labs, including Argonne, Oak Ridge, and National Renewable Energy Lab. But our industrial partners are very important to us. There's a lot of the people who guide us in terms of, some of the state-of-the-art components out there, exactly what the operating conditions are. They do much more in terms of cost type studies. So we are working with a project led by GM. You can see their partners, one by Nikola, who is a startup company out of Arizona, Phoenix, Arizona, Carnegie Mellon. Then there's another set of projects that are for high temperature membranes, one being led by 3M, one by Tennessee, one by Lubrizol, and another by Nikola. And then there's 2 projects that are led by Plug Power. Plug Power's been in the press a lot recently. They've been selling a lot of fuel cell forklifts. And then people are familiar with Cummins, who makes a lot of the diesel engines out there. And so they're looking at what their engines of the future are going to be. I obviously don't do this myself. I did want to introduce our team and all the people that work on our team. We have a reasonably good staff science background. Our staff scientists have over 200 years of experience. We have over 25 PhDs. We have a good set of postdocs and students, and we've used postdocs and students throughout my entire career and use them extensively. And then we also make use of visiting scientists. And so they come from all over the place. I think you can just see from the pictures. I should acknowledge that most of our funding does come from DOE EERE, Energy Efficiency and Renewable Energy, Hydrogen Fuel Cell Technologies Office. We do get funding from other places, including NNSA, CRADAs with companies. We make use of LDRD as an example.
Could you define just a little bit, real quickly, what's a CRADA and what's LDRD
Yep.
for non-labbies?
So CRADA is Cooperative Research and Development Agreement, and that is typically us working directly with a company. Sometimes the money for us will come from Department of Energy, and sometimes that is funding from the company. LDRD is Laboratory Directed Research and Development. We use the laboratory LDRD program really to get into new areas and new spaces that are too early for example, the Fuel Cell DOE program office to fund. So at this point in time, I've just got a schematic related to what a fuel cell is. And Los Alamos has really been the leader in developing new membranes and new catalysts, new electrodes in this. And so I did bring a show and tell. It's going to be, I think, maybe hard for some people over the WebEx to see it. But just to give an example, and I can show Linda the different pieces. Hopefully you can see this if I can get it under the screen. But this is what a membrane looks. It looks a little bit like a little piece of saran wrap. And this is a proton conducting material. You can touch it and hold it under there.
That is very, very light.
So
Further this way. Yes.
you want to get it under the picture. So then this
And maybe
is...
let's get that out of the way so you can actually see it, if that's all right, Rod.
Yep. Then this is taking a piece of membrane and putting catalyst on it. And that's what we call a membrane electrode assembly. I brought a whole bunch of membrane electrode assemblies with me. And the point that I wanted to make with the different membrane electrode assemblies is these are all catalyzed pieces of membrane, and you see that they're all different shapes and sizes. And that's one of the advantages that fuel cells have is we can stack up the cells, and that's typically why it's called a fuel cell stack, to get the voltage we want. And the different areas are used by different companies depending on what they're trying to do, and it can really lead to how much current that you want. And so fuel cells are very scalable. They're typically much more scalable than batteries, depending on what powers, voltages, and current densities you want. So this is really the inside of your fuel cell. And then we have what are called gas diffusion media. And this is a carbon fiber with a carbon black on top. You take these.
Come on under. We're not. Oh, we've frozen, Mel.
Oh, I got it.
Do you need me to push the button on the
Try
Elmo?
again, try again.
No,
it's not
no,
showing
it's,
what I'm showing.
it's, yeah.
We'll have to come back to it when we're.
Here, hang on. Didn't do anything. Oh, darn.
Well, in the bottom right, those are the GDLs that I'm holding here. And when we take those GDLs and we sandwich the membrane electrode assembly, that is the basic internal components of a fuel cell.
How many layers does a fuel cell typically have?
It all depends. And if we can ever get back to the camera,
We won't.
what I'm going to show you.
Want me to turn it off and on, Mel?
Give me a second here.
But Linda, to answer your question, it depends what voltage you want.
Mm-hmm.
So out of the Toyota Mirai, if I remember correctly, it looks like it's working now.
Hey, all right, great.
So this is a gas diffusion layer, and then you sandwich the MEA with two different gas diffusion layers, and then you have a full cell. But this is the full active area out of one cell that came out of a Toyota Mirai. And it's got all kinds of fingerprints on it because I use it for show and tell all the time. But to get back to your question, the Toyota Mirai has, if I remember correctly, 370 of these.
370 of these layers.
Yes.
Okay, and how big of a unit then does that create in the,
I don't know how
Like-
many inches. I mean,
about as big as a microwave or your typical microwave oven?
Yeah,
Something like
something
that?
like that.
Something like that, yeah.
But in terms of and you can hold this if
Okay.
you want. Los Alamos does make our own stacks for our own special purposes, and this is one of the teeny little stacks that one of our staff scientists is designed, and there's 8 cells in this one. And
And what might that be used for, that little guy?
well, it's used for some of the core mission at the laboratory.
Okay,
So this is another one. It also happens to be 8 cells, and I think you can see the cells inside of it. And you can see that in this case we need a whole lot more current out of this one, and that's why we designed them for different sizes.
neat.
And of course, the thing that people are typically in our world most interested in is catalysts. I didn't know how to show catalysts, so I just brought a vial. This is some of the catalysts that we made in our group, and it happens to be a platinum alloy catalyst. We alloy it so that we get better activity and we can use less. And so it basically looks like a black dust.
And then how do you create these layers? How do you, like, anneal them onto there or
So-
whatever you do?
There's both art and science in making these electrode layers. You can make them in decals and then press them on the membrane. You can do a screen printing process. You can do a roll-to-roll process. And we're trying to put as much science into making these as much as possible, but like I said, it's in some cases a little bit still of an art.
That's great. Thank you for describing that. That was really helpful to be thinking about it like screen printing.
So can I go back to my slides now?
Here we go.
Thank you.
Great.
So in terms of the Los Alamos program, I've just got a few more slides. And I did mention that we do make new catalysts, new membranes. We work on durability. We do a lot trying to understand electrodes. And we are the only national lab that goes all the way down to sub-nanometer particles. This is a single atom of iron for a platinum group metals free electrocatalysis. We are working on trying to get rid of the platinum, and this is an example of a micrograph of platinum particles, then going all the way up to your MEA structure, and then I did show the fact that we do make small cells at times. So I mentioned we work a lot with industry. This is just a demonstration of, we have pulled our industry partners and said, what do you want us to work on? What do you think are the priorities? And we expressed it into a word cloud, which seems to be a new thing, and people seem to like them. And you can see what industry said they want us to work on. It varies at what time and what application they want us to work on it. But for the 1,000,000-mile fuel cell truck, number one is durability. These have to last 1,000,000 miles. Go figure how we came up with the name. So in terms of our approach, we are working with the other national labs and we're working with industry. So we have a big emphasis on the systems analysis, understanding how the trucks work, because these are relatively new. There's only a few demos out there on the road. We need to know what temperatures they're going to operate, how they're going to climb hills. We are making new materials that includes membranes and catalysts. We then take all those, we integrate them. We're sort of science-based, so we're trying to understand exactly how those materials interact. And of course, number one on that list was durability, and that's something that Los Alamos has had a strength in, is in terms of understanding the fuel cell and different component durability. So there's a lot on this slide, and I don't want to go over it all, and this is actually my last slide. But it's sort of talking about the 1,000,000-mile fuel cell truck, and it's a 5-year consortium. I showed all the partners. But for example, we are starting out with a whole lot of analysis, doing materials baselining, trying to figure out how many of those materials we think will work in a truck. At the same time, we're going to be doing more and more materials development to try to get up to the durability mark that those 1,000,000-mile trucks have to get into. And that, of course, doing the durability, doing the integration, getting those together, and then finally our end goal is to come up with a membrane electrode assembly that we can hand to industry. We're not going to commercialize it, we're not going to make it, but we're working with the people that will eventually commercialize it and sell it. And then you can see the targets are in essence 25,000 hours, and that equates to about 1,000,000 miles. So I'm gonna, I think, stop there. I've already done the show and tell, and then we can maybe try to answer questions.
Great. We've got a bunch of great questions, and thanks so much. And what a great target to have to be aiming at, with such great support from the highest level of our government here. So we have some questions here about fuel cells, and our good pal Steve Schreiber asks, how do fuel cells perform compared to batteries in cold winter weather?
I don't know that I'm the expert in batteries. I know batteries have some issues in cold winter weather. DOE had a set of projects that they funded. It was primarily industry about freeze related. So you don't you don't operate a fuel cell at low temperatures. What you do is you let the waste heat of the fuel cell heat itself up above freezing. And you really have to do that because the product coming out of a fuel cell is water. And so if you make water, it's going to freeze below sub-zero. You know, if I just go back to this slide, nobody from industry is telling us to work on freeze. And Toyota and Hyundai and GM will all tell you that, you know, they can self-start a fuel cell from minus 30 C, and then they need assisted startup from minus 40 C. But the number of times that they think they have to do unassisted self-startup from minus 40 C is a pretty small number. So they're actually happy where they are in terms of the freeze operation for a fuel cell.
The high temperature is on your graph there, but is that a high temperature of something else, not native high temperature when you're operating it?
So high temperature to us is sort of maybe misleading a little bit. We typically operate this membrane at about 80 degrees Celsius. If I was quick, I could convert that to Fahrenheit, but I'm not that quick. But, you know, sub-boiling point of water. One of the big issues you end up with fuel cell cars is actually heat rejection. In an internal combustion engine, it runs very, very hot. Most of your waste heat goes out the tailpipe. But you have a very big difference in temperature for your radiator to work at. So it is a challenge to do the heat rejection. So companies would really like to operate this membrane closer to 120 degrees C. That would make heat rejection easier, and that's why the high temperature is on that slide.
Oh, that's
It's not high temperature in terms of hundreds and hundreds of degrees C. It's 120 degrees
Yeah,
C.
yeah, fascinating. A question from Alexander: how does a fuel cell car feel to drive? And you've driven them. He asks, is it quieter than ICE, noisier than battery?
I've driven three. I've driven the Toyota, I've driven a GM, and I've driven the Hyundai. And I do happen to own a hybrid, which happens to be a Ford. And so when I'm backing out of our garage, it's only on the batteries, and your fuel cell vehicle is basically like a battery vehicle. You know, the noise is really the tires on the road. You don't hear anything from the fuel cell, at least in the versions that I've driven. So much quieter than an IC engine, you know, very, very typical of what sounds like a battery vehicle.
And I know this is the truck challenge, but Edward has a question. What about trains, especially freight trains, which would seem to be even a better bet than long-distance trucks?
So I'm going to go way back to my hydrogen at scale slide, just so I can point out that there is a ship and heavy-duty truck, actually that's sort of the medium-duty truck, and a locomotive on there. So we have not worked specifically on locomotives, but this is applicable to trains. There is a German fuel cell train that I believe is running in Germany. It makes a lot of sense for locomotives, but in terms of what DOE has asked us to work on, they've asked us to work more on the heavy-duty trucks, and part of that is in terms of the diesel engines on trains, they're significantly more efficient because they typically run them at 1 RPM. And so I think the greenhouse gas reduction is probably less. But what you're going to do is you're going to take the fuel cells that you develop for the heavy-duty trucks and then just use more of them on trains. But it is an application that we all have in mind, and the big marine shipping as well.
Right, right. And of course, then your infrastructure for fueling up is very
It's
easy to
probably
control.
even more localized.
Yeah, right. So The next question references this interesting layer that I was holding. You said this is the one that came out of the Toyota car, right?
Correct.
All right, the question is, do you know the cost per layer for that one that came out of the Toyota car?
I do not. Just before this, I went and looked up my numbers in terms of how much platinum there is in the Toyota Mirai, and the amount of platinum works out to be $1,100. And I can tell you that at least the last time I looked it up, the price of a Toyota Mirai was exactly the same as a Tesla, and I think Toyota did that on purpose, is they wanted a one-to-one comparison with Tesla battery vehicles. But that's in terms of manufacturing, that's typically something that the companies aren't going to share with us. We know what's in there. We can calculate the cost of the platinum, for example, and they will guide us to, we want these components to be cheaper, but they're not going to give away their trade secrets. Now, one of the things about cars, and there's a very good reason why I have to sell a lot of the Toyota Mirai, is once you start selling things, people can go buy them. And so people have gone and bought them. And this was provided to us by U.S. Car, which is actually a body that involves both GM, Ford, and Chrysler, and the Department of Energy. And so we were given some of the cells that are out there commercially so that we can take a look at them. And our goal is not to reverse engineer anybody's technology. Our goal is to understand it and help both the national labs and universities understand what the state of art is. And so if you come up with a better catalyst, this is what the better catalyst really has to do, because this is actually what's out there in the cars.
Right, real practical application, going from that practical application back to how do we even help you make it better?
Right.
Yeah, yeah. Question here from Rick, when will the fuel cell truck be commercially available, do you think?
So again, there's both existing companies working on fuel cell trucks, and there's some startup companies working on fuel cell trucks. And I mentioned Nikola, that is based out of Phoenix, Arizona. Their business plan is pretty interesting because they want to sell both the hydrogen and the trucks. I actually haven't paid a lot of attention to when they intend to be releasing their trucks. I think they've said in the next 2 to 3 years. There's also a startup company out of Rochester, New York, and what that company is doing is a little bit different. They're taking existing vehicles and retrofitting them with fuel cells. And 2 or 3 weeks ago, I did see a press release from them where they had signed an agreement to provide 70 medium-duty trucks to some company in Austria. And I think you're going to see small fleets of vehicles before you see massive numbers of semis. And some of it is where the technology goes, but I would expect in the next 3 to 5 years, you're going to start actually seeing them being demoed in decent numbers, similar to what we're seeing today in cars.
And Rod, you mentioned when we talked earlier, before this presentation, that an interesting application would be, let's say, a shipping yard that uses a lot of trucks to get things around to the ships. And that little fleet, that would be like that little incubator project to make that fleet of trucks work.
Yep.
Yeah.
So, I mean, the part of the interesting thing with the Department of Energy in Los Alamos is the Department of Energy asks us to work on the hardest problems. And the hardest problem is really the long haul. I've got across the Rocky Mountains Class 8 trucks, but people are working on what are called drayage vehicles. And that's port inside of LA, going from the ships, getting the goods out of the port. And people are very interested in that, some because of the CO2, but a lot because of the pollutive emissions. And, ports tend to be some of the dirtier areas in the country. And so if you can get those emissions out, no particulates, it really helps clean up the environment. And one of the big targets of the current administration is what I hear referred to as energy justice, and that is really trying to get clean energies everywhere, and that means into economically disadvantaged communities. And one of the analogies that I've used, I haven't heard the administration use it, but rich communities, people can go out and afford to buy a Tesla. In economically underdeveloped communities, people are not buying Teslas. And so that is a big goal of the Department of Energy, is to clean up emissions in the underdeveloped, economically developed communities in the country, and that includes things like ports.
Right, where many polluting industries were located and cause a lot of health issues, et cetera. Yeah. Let's see. My questions kind of all scrolled back up. Let me see if I can get down here and see. Come on there. Oh, here we go. Let's see. So thanks for talking just now about the trucks. This question is about, cars. How long do you think it will be until fuel cell with battery-powered cars are the normal in America? And do you think they will ever become the norm?
So that's an interesting question. There's a lot of modeling studies out there. Probably none of them are right in what they're predicting. But right now the Department of Energy is predicting approximately 50% of the cars sold by 2030 will be battery cars. And I think nowhere in this discussion did I actually comment that all fuel cell cars are actually hybrids. And so there's a fuel cell and there's a battery on it. So just like you can buy an internal combustion engine hybrid car today, the fuel cell cars will be hybrid cars. And one of the things that I'd really like to see is in the cars that are out there, and going back to my pictures of the cars, none of these are plug-in hybrids. I'd really love to see a plug-in hybrid fuel cell car, but none of the companies have come out with them yet. I'm not quite sure why, but I think that would be something that people would buy before they would buy just a complete fuel cell car. Because the people that I know, and I know a few people that have the plug-in hybrids, the game that they play is to try to never actually operate off of the engine. They try to just run off the battery and get back home and charge it up before they have to. So 50% of the cars by 2030 they think will be battery vehicles. I think that's an ambitious goal. We'll see if they make it, because today it's only about 1.5%. So there's a long way to go by 2030. So you see similar numbers of predictions in terms of fuel cell cars, and really I think to get to net zero CO2 emissions, that's probably where we have to be, is 100% electric vehicles by 2050, and the numbers that I'm seeing are maybe up to 50% fuel cell vehicles by 2050. But again, those are predictions. That's a long way off. And I think it remains to be seen.
Right.
And then there are probably some people that will never give up their classic internal combustion engine cars, so they probably never disappear. But one of the things to recognize is even by 2030, if 50% of the cars sold are battery cars, that only means about 14% of the cars on the road will be battery cars, because people are driving cars longer and longer, and the average turnover of a car is something like 14 years now.
Really? It's that long? The average turnover? Wow. So something else in the whole equation of for fuel cells is Los Alamos National Laboratory working toward technology that provides hydrogen generation from solar electrolysis.
So a couple years ago, we had a project that was called PEC, photoelectrochemical water splitting. And so that was direct sunlight to hydrogen. The staff scientist that was working on that, unfortunately, left Los Alamos. In terms of other solar technologies, once you make electricity, any electricity can be used for electrolysis to make hydrogen, and we do have a set of there is a different consortium out there. It's called H2New, and we have a significant role in the H2New consortium because it uses similar materials that go in a fuel cell for hydrogen production. But we don't currently have anybody doing the direct solar to hydrogen. It would be solar to electricity to then hydrogen.
Let's see. Is there research being done to use fuel cells in other fields outside of transportation?
So again, we talked a little bit about locomotives and marines. All of those are being explored. The biggest purchaser right now of fuel cells is actually people like Walmart and Amazon, and they're buying a lot of fuel cell forklifts. And there again, you can have a localized hydrogen infrastructure, where you just have one set of refilling station, and they're finding that fuel cell forklifts in a lot of cases will beat economically the battery forklifts that they have out there. And you can imagine, driving a forklift inside of a warehouse, you really don't want the emissions. So that's really probably the number one area that fuel cells are going is into the forklifts. There are people working on home stationary. That hasn't been economically a popular place to put them, primarily because of the hydrogen. And people have been looking at some of the high temperature fuel cells. And when I say high temperature in that case, I'm actually talking about 700 degrees C fuel cells. It's a different type of fuel cell than what our program typically works on. But stationary. And actually, there is a light plane. I think it seats like 8 people that they have demoed off of fuel cells, UAVs, the octocopters and 6, I guess, hexacopters. There are some companies making fuel cells out there, and you can get 3 and 4 times the amount of flight time out of your little UAV. And there's a lot of people that are interested in that.
You just raised this when you said don't want the hydrogen around. So Steve Schreiber brings up common public knowledge is that hydrogen equals the Hindenburg disaster. So how do users of hydrogen as a fuel convince the public that it's safe? And can the distribution infrastructure be made as safe as that currently accepted for gasoline, propane, or diesel fuels?
So it's a question that comes up every once in a while, which is the Hindenburg. Hydrogen is extremely flammable, and one of the things with hydrogen is the ignition energy to ignite hydrogen is very small. But gasoline vehicles, when they were first introduced, I've got a slide somewhere, someplace. I didn't include it in this presentation. But gasoline vehicles were not widely accepted for a long period of time because they were much more dangerous than what they were replacing. And of course, what were they replacing? Horses. And horses tended to not burn. There are natural gas vehicles out there, and I think we've all seen the unfortunate accidents where gasoline vehicles burn and natural gas vehicles burn. I've also, collected videos of Teslas burning. And so it is something that, people are concerned about. DOE does have a whole hydrogen codes and standards effort. It has a public education effort so that people understand what's right and what's dangerous about hydrogen. But then I go back, and there was a study back in, I think it was the 1980s by NASA, who were looking at hydrogen fueled in essence, transportation, so jets, big jets fueled off of hydrogen. And they did a modeling study about what happened if a jet crashed on takeoff, and what happened with the hydrogen. And what they found is that hydrogen is so buoyant, the hydrogen actually will burn above the cabin, as opposed to your jet fuel. All of these things are flammable. People have accepted the dangers with gasoline. What we have to do is get to the point where hydrogen is equivalent in terms of safety and get people to accept it. We haven't seen with the fuel cell vehicles out on the road an issue with the fuel cell vehicles. There was a study done by Sandia National Lab where they ignited a hydrogen, they penetrated the hydrogen tank and let it burn, and indeed the hydrogen did burn above the car as opposed to gasoline will go down and then burn, and so it burns the car. But that's not to say that that's going to happen every time, and obviously if you form an explosive mixture, that's going to be different. But all of these fuels have dangers to them because they are very high energy density fuels. So I don't know that that's a perfect answer to that question, but it is something the Department of Energy and all these companies are very closely looking at and trying to make sure. In terms of, I mentioned, I think there's something on the order of 40,000 fuel cell forklifts out there that are owned by people like Walmart and Amazon. When they first introduced them, the stories we were told was the people didn't want to drive them. After they started driving them, they really liked them, and now they don't want to drive the battery forklifts. So, it is an acceptance, and it'll take people a while to get to
Sure. Yeah.
get to accept the new technology.
Yeah. I think we're out of time, and I think talking about safety and that they're making progress on that and looking at it is a really good place to stop. So, Rod, thank you so very much.
Well,
this
thank
was
you.
a really great topic to talk about, so timely, with the words from the President and from our Secretary of Energy just coming out recently. And thanks so very much for bringing us up to date on what you're working on here.
Well, you're welcome, and thank you for inviting me.
My pleasure. So everyone, thank you also for joining us, and thank you for your very good questions, really great exploration. I look forward to seeing you, I hope, in person at Science on Tap on July 9th, that's Friday, on the lawn of Fuller Lodge. Thanks so much, everybody. Good night.